This is another Concept Bite video, this time again on statistics, but looking at the range. Here I have two sets of data, pictorial representations of data. Dataset 1 has a mean value with the data spread quite close either side. Dataset 2, the data is far more spread, but the mean value is exactly the same as it is in dataset 1. The important thing to note from this is that the mean, the average value, doesn't tell us anything about the spread of the data. Here I have some number examples of it, where the top data set varies between 9 and 11, and the bottom set between 9.8 and 10.2. The mean in both cases is the same at 10.0, but my mean tells me nothing about how that original data was spread. This spread is important. It tells us how well we can measure something. It tells us how confident we are in our values. And we have different methods of looking at this. This video is specifically looking at the range and the range error. There is another video which looks at variance and standard deviation. Range is quite simply a measure of the spread of the whole data set, the maximum value minus the minimum value. My range error is this difference between maximum and minimum, my range, divided by the mean value. The range error is not necessarily a very useful thing because it doesn't give me the same units as what I initially was using to measure, so it can be slightly difficult to interpret. But for a rough and ready calculation, it gives us some idea of the confidence we have in our mean. So here is some initial rate data. I can see that I've got 5 data points spread. My maximum value and my minimum value are used to work out my range. And my range has the same units as my mean value or as my initial data. So in this case, my maximum value is 1.45, my minimum 1.24. times 10 to the minus 4 moles per decimeter cubed per second, giving me a range of 0.21 times 10 to the minus 4 moles per decimeter cubed per second. I find that keeping the power the same as it is for the original data is a good way to not confuse significant figures and to give me a good estimate of where my uncertainty, my range, lies compared to the rest of my data. So I'm going to leave this as 10 to the minus 4. My range error is calculated simply by taking my range that I've calculated on the previous page and dividing it by my mean value. Here I have a range error of 0.16. Sometimes this is listed as a percentage error, so I've multiplied this value by 100 to get 16%. But as you can see, this doesn't really give us a huge amount of understanding of this value because it's not related to either the original data or to the units of the original data. This is a weakness of using the range and the range error as a measure of statistics, but it's considerably faster to calculate than the alternative method, the standard deviation and the standard error. The range is a rough and ready way to find out about the full set of data. Range has the same units as the original set of data, but range error has no units. One thing that's good with range error is it's a very quick way to go forward with calculations, particularly based on multiplication and division, but we'll see that in another video. I hope this has been helpful. Ask if you've got any questions.